And right above it, I saw the answer sheet for the calculus competition. And I was like, dang, why is she texting about the competition? We just did that. And so I answer according to the competition. But then I didn't even see the next text that you sent, which was like, what the heck?
I was like, wait, what?
Yeah, and then
I didn't even know that was a competition. I was just like,
no, but then
I was like, man, I got that really wrong. I didn't know this was multiple choice.
Yeah, and then it was like 9:30 at night, and it was like, oh my god, she was talking about the test. And it just hit me. And I was like, I walked in my room and I was like, Olivia, I'm so it was really bad. I'm sorry.
Yeah, you're good. I was just really confused. I was like,
you answered B.
Yes. Well, I asked her if she happened to understand number 11, and she said, I got B. And I was like, what?
Yeah. And that's funny. You know what? It's been a rough semester, and now my head is not working, and my brain is fried. Answering letters. Yeah.
Last week was just too much for me, because I had like 2 exams, a college interview, and 3 subject tests for the SAT.
Where did you interview at? How did it go?
I think it went
Were there
really
any
well.
brain questions?
No, there weren't.
Cat is making that up. I know.
Yeah. There wasn't any of the think creatively kind of questions. It was more basically the interview.
Like questions that they'd actually want to know the answer to. Imagine that.
Yeah, and it was also a lot about, she asked me to tell her about myself, so I did, and then she went back through and wanted specific details on everything. Because she said basically what they do is your interviewer is going to be another recommender. Like, they're supposed to go write a recommendation letter based on what your interview had to show. Mm-hmm. So they're looking for something interesting that stands out. And that's pretty much it. And it was really low stress. It was really casual. I was still freaking out. I got to Panera like an hour early. Just in case she got there early.
That's great.
Yeah.
This is going to be my 3rd notebook for this class.
Nice. This is my 3rd notebook, but the other ones were mostly used from other
this
years.
was just a practice for another interview.
I mean, if I have another interview. I don't know what the next, I think they have another interview at the next round. I'm just glad I made it this far. I'm terrified though. MIT isn't.
Yeah.
It is. But I really want to. But my biggest worry right now is the final exam for this class.
Same. Or the test that's on Thursday. Either one of those.
I may have gotten a B on this test, or no, it was a C. But it was the best test I've had. Because the ones I missed, it was like I missed pretty much most of the problem, and I had some that were completely right that I didn't have to redo it, and it was doing really good. Because I started it really late last night thinking, oh my goodness, this is going to take me forever, and then I was like skip 9, or 8, 9, 10. Yes!
I got like, when I was doing this, I got number 2 totally right, and I had done everything but like actually write down the answer before I was like, oh yeah, I'm doing this, I got it all right. It's really bad.
I almost got 2 right. I didn't leave it the exact answer. I actually solved it, like I plugged it in my calculator and got the decimal answer. But instead of just, counting it right because I did it right and I got the right answer, I just took it a step too far. I got a 1 top and I had to redo it. And then for number 12, I wrote half a page. just to cover all my bases. I don't know what exactly that's looking for.
Yeah, yeah, done. Like, yeah.
Good morning, Josh.
Oh, I figured out what we did wrong. We did it on the wrong end. I mean, you have to solve for 0. You have to set it equal to 0. So it should be for the first one. X is less than or equal to -1. And then the negative of that is between -1 and 4. And then greater than.
How was the robotics competition? Good.
Was a couple of days.
So I missed it.
Good. And about 30 teams. The gym was slammed full of people.
It planned on coming, but asthma.
Oh, okay.
Can't be
No.
can't be in a robotics competition. Can't breathe.
That's right.
Them's the rules.
And the excitement, that kind of crowd, too.
Yeah, that would have aggravated it.
So I have your extra credit. I'll go and collect that one. Got it in there for you to start.
happens through photosynthesis.
Okay. Let's see. Sammy, Josh. Good morning, Davidson. Can you hear us over there?
Yep. Good morning.
All right, so I thought this morning we would talk a little bit about what we did last week on the area between two functions, maybe an example or two. So here's an example. So the first problem is just like we talked about last week, which is find the area between two functions on a given interval. How do we start? Number one, we'll just do the integral of -2 and 2 of absolute value of f of x minus g of x. What's that going to entail for us, though? Before we get to that, I want to stop for a moment and draw a picture. What's the picture of this look like? Maybe I need to make that. Four minus x squared would be, let's say that's 4. Let's see. Something like so we're looking for the area between these two functions on the interval from -2. What's going to, how's it going to affect it based on that? Wow, what now? Let's see. Yes, we want to find the intersection point. That's right. So, how do we do that? So go ahead and rewrite this as maybe 2 of this code minus x. So go ahead and subtract the two functions. But then Madison suggested we find the intersection point between the two functions. Okay, good. How do we do that?
I sound like the US stuff.
I'm just waiting on a simple recalculus algebra question. And her response was, it must be Monday morning. One more time, the question is, the suggestion was, find the intersection point between the two functions. It's a good suggestion. Now the question is, how? So two functions equal. Good. Okay, so we'll set f of x equal minus x squared equals x squared plus x plus 1. Okay, that wasn't so hard. Seemed like a struggle, but it wasn't that hard. Now what next do we need to do? Found the intersection values. That's because the function, the idea of finding area is you want to be able to take the high value minus the low value to get the height. You want to take the difference between the big number and the small number to get the height of the rectangle. That changes when it's, whether it's in here or, for example, out here. Or out here. So which one's the big and which one's the small changes depending on where you are on the x-axis. Which is why we have the absolute value, because it makes all of it become a positive height by taking absolute value. But in order to actually deal with it, we have to use the definition of absolute value and split that function at its two places of intersection. So I got from -2 to -3/2 of that, something about that function. Is it going to be the positive or negative of that function? That's the question. So if we're left of -3/2, oh, what we have figured out, folks, is this point right there is -3/2. That point there is 1. That's what we figured out. So if we're left of -3/2, which one's the big one? Gx is the bigger of the function. So if we're doing f, this is f minus g. F minus g out here would be a negative number, would it not? So therefore, I got to take the negative of it to make it positive. So this is actually negative of -2x squared minus x plus 3. Then from -3/2 to 1, in the interval in the middle part here, we see that f of x is always the upper function, meaning it's a bigger value than the g of x function. And so subtracting f minus g will automatically give you a positive number, so I don't have to do anything to change it. So this just becomes -2x squared minus x plus 3. And finally, the last section from 1 to 2. Once again, we've hit a point of intersection, so they switch orientation again, and f becomes the lower function, g becomes the upper function. So to make it an automatic positive, I have to switch the sign. You with us here? I'll go ahead and calculate a number. See if we can get our mental juices going on Monday morning here. Get a number for me. We'll compare those numbers in that. We'll do the other problem. the video quality on David's side today? Is it okay?
Yeah. Sure.
Y'all getting good video quality today, or okay video quality? Dave?
Yeah, it's pretty good.
It's fine.
Thank you. Have any numbers yet?
What'd you get for just the first one? Is that what you got for your derivative function? Okay.
I'll take a shot. You're not big. That negative play. Really funny.
It's one you made up.
Okay.
It's just like that little bit. How is it supposed to subtract the difference?
What are the things that go here? Is it this and this?
It's two.
Let's go in there. Oh, you made me take off the mask. Mask. I guess it's not okay here.
Once it has a number yet they want to have it? 1.082, I heard. What do you call that approximate? What's the number? Second on that? No, we won't risk it here. We'll wait until the test, and when it's high stakes, then we'll risk it.
Don't risk what?
Getting around.
I'll tell you what.
I'm plugging in -3 into the
I'm not done yet.
negative. Then I'm plugging in -2 into the anti-drift. Then I'm plugging in a 2 and a 1. So it's 16 thirds. That's 2 minus 6 minus. Plugging in a 1 is 2/3 plus 1/2 minus 3. So this is where I am so far. I feel get an exact answer on that. Might be 9.0. And so this was just f of -3 minus f of -2. This is f of 1 minus f of -3. This is f of 2 minus f of 1. Okay. 9.083. Do it exactly. You hit fraction. I'm not at the which is approximately 9.083.
How did you get that?
Okay, good. That was one problem. I think the test is on Monday morning. Might not. Okay. So, second problem, hopefully it won't take as long. The second problem says on the interval from 0 to 3, back over here. So on the interval from 0 to 3, how is that going to change the structure? Yeah. So by not including that left intersection point, we're only starting at 0 at the y-axis and going out to 3. So we'll have one change at x equals 1. So you'll just do 0 to 1 and 1 to 3. But you can do that in a moment. Next question, the third question is bounded by. So where's it says find the area bounded by these two functions. What do you think that means, bounded by? Yeah, bounded by means completely encapsulated by the two functions. So it will only be between -3/2 and +1. And since in that region there's only one, you're not changing the orientation of the functions. That will be easy. No. So let's take a couple minutes to see if we can get the answers to 2 and 3 so we can compare those real quick. Then we'll do another problem. Because here's, folks, this is your opportunity to practice and get your answers checked before you have to do it for high stakes on Thursday.
We get to practice and check our answers to the test.
Area which manage two functions. So I have this nice little graph of the two functions. I can just put where the intersections are, and so that we saw that's not right. Just like think about where is -2 in this so it's less than something like that. Do you have that solid district of the negative?
Not bad.
Yeah, you use the one. So you start with
Which one is that? 0. So it's 0 to 1. 1. Is that 2 to 3? What did you do? 0. That's not possible.
It's not possible.
I know, but it's like I did exactly what they did, where you take that minus that. You continue to do it. She made a little face.
Yeah. Yeah, so that's just from -3/2 to 1.
You need any numbers on the second one yet? Anyone wants to share? Okay. 7 and 2 or 13.5. Okay. Everybody else get 27 over 2 for the second one? Get a second, third, fourth, good, fifth. Okay, good. So I think 27 over 2 is correct. How about bounded by? The word bounded, of course, it indicates encapsulating. So we're not going outside of the intersection points when we say bounded. Might get a number for bounded. Not yet. So that's just going to be the middle one from last time. Sammy's got it? Sammy.
I have a question about how you got number 2, because I ended up with 17.2.
Okay. Well, I don't know. Let's try it. I didn't do it, but I got several people who said they got that number. So let's see. This time we're doing from 0 to 3, so we got to do from 0 to 1 of f minus g is going to be positive in 0 to 1 intervals, so I can just do negative 2x squared minus x plus 3 dx. Then from 1 to 3, they switch order in terms of who's high and who's low. So from 1 to 3, I've got to do the opposite of that. To make it a positive area. So from 0 to 1 is just going to be whatever we had before. Down here. 2/3 x cubed plus 1/2 x squared minus, well, plus, what did I do wrong?
Aren't the signs supposed to be opposite of what they are there?
Yeah, I'm copying up the wrong row. Thank you. Good catch. 0 to 1, and then this one's supposed to be side of this. So this should be 2/3 x cubed plus 1/2 x squared minus 3x from 1 to 3. So whatever that gives me, so 1 is going to be negative 2/3 minus 1/2 plus 3. And if I plug 0 into all this, this is just going to be a 0. Then I got to plug a 3 in and a 1. So whatever that is, 27 divided by 3 is 9. So 18. 9 halves minus 9. And minus, plugging in a 1 is going to be 2/3 plus 1/2 minus 3. That's what I would get, and then just find like terms here. So, Sammy, if you would just add those up for me real quick, and see if we get 27 halves, or if we get something else.
Could also be negative 37.
I'm not sure that's. I don't know if that's good or not. This is what I got. Negative
Yeah,
18.
I got again the 17.17. The 17. I got 17.2 again when I added those up.
Okay. So apparently that number's wrong. Where did I get your question was where did I get the 18 from? I had to plug a 3 in here. 3 cubed is 27 divided by 3 is 9 times 2 is 18. This was f of 1, this was f of 0, this was f of 3, and this was f of. What was that exact answer, Sam, that you got?
The exact answer was 103 over 6.
Yeah, I got that too.
Okay. So we had several people with a different number. I'm guessing maybe, I don't know what happened. This is what I would get. Okay.
Why doesn't he try real fast?
Those who got a different answer, did you do something different from what we did? Because several people got this answer. We have several voting one way and a few of us voting the other. We need to come to an agreement.
Well, maybe we could try it all the way through.
half my democracy.
I'm thinking group. So
Yeah, well, yeah.
That's a different phenomenon.
Wait, what part is this?
Wait a minute.
Yes.
In his second one, he has 18 plus 19 over 2 minus 9, and then the second one it's minus. But in between that, shouldn't it be the same thing as what he had for f minus 1 in the beginning? But it's not. It's just 2 over 3 plus 1 half minus 3. And it should be negative 2 over 3 minus 1 half plus 3. Right?
What?
No, because it's supposed to be the f of the x minus the g of x.
Mm-hmm.
And since they switch, they cross over, you have to change the signs on the second one.
That's exactly right. The interval on the picture over here, let's go back to the picture. So on this picture, we're looking only at the interval from 0, there's 0, to about 3, there's 3. Part of the time, the rectangles are going to be like this, where the f function is going to be the big function and the g function is going to be the small function. So you're going to take literally f minus g to get the height of the rectangle as a positive number. But when you get outside of the number x equals 1, then the rectangle switch orientation. G is now the big end and f is the small. So since we set up the whole problem as being f minus g, do you understand that to get this height right here, height is equal to g minus f. That's all I'm saying right now. And this height on the first rectangle was height was equal to f minus g. Well, that's just graphically looking at it and thinking of height as the high minus low. But since we wrote it algebraically as f minus g in the beginning, we put absolute values on it, which is going to force us to switch that orientation by taking the minus of, when we switch orientation, notice that if we're doing f minus g, which is what we've been doing all along, then if I take the negative of that, I get g minus f, which gives me the correct positive height. We're always looking at it in either one way. You can think of it geometrically or algebraically, but you're going to get some kind of minus in there to switch the sign one way or the other. Well, yeah, that's exactly right, Sam. We had the second part here has an opposite sign because we need g minus f. So you can either just simply do g minus f, or you can do the negative of f minus g. Both ways give you the same answer. Does everyone agree with that? That g minus f is always equal to negative of f minus g. So however you want to think of it, you need a positive height. Okay. So I think this is right now. Everyone able to get to that number? Okay. The last one real quick. Anybody get that bounded one? That's going to be simply, the bounded is simply going to be the middle one right here. Actually, let's see. I think
What happens?
f of b minus a. Yeah, 1 minus, yeah, this one right here. So whatever this middle one was a moment ago, that would be the answer to the third problem. Right here is this is the answer to number 3, whatever that is. Take a number for that. Almost that. No one wants off their numbers because they might be good numbers. 125 over what? So 125 over 24, I heard. Number 3. 125 over 24. Anybody else get that?
I did.
Well, yes. Okay, good.
I did.
Well, here's another problem to really gnaw on a little bit. This one's in the book on page, so I'm going to use the right-hand board now.
What was the answer?
On page
125.
87,
The original one.
Yeah.
well, we need to calculate the area inside this giant W.
Is that like Satanist McDonald's?
27 over 2.
It's upside down McDonald's. The book just not wanting to infringe on McDonald's rights, they call it Wally's Burgers or something, and use the W instead of M.
Yeah.
Okay, so they give us functions defining pieces of this W.
Alright.
I've written those functions up here. I don't know if you can spot them. So f of x is a parabola curve that starts up here, comes down, hits the x-axis, and comes up. It would actually continue on, but it intersects this curve, which is called g of x. So g of x has a x-intercept at 24, which you can see right there, x minus 24. That's going to be an x-intercept for it. So it forms this part of the right part of the W, and then the upper part is two different functions that are similar to the original. So above the f function is the r function, and you notice it has something with a minus 12, which means it's been shifted to the right 12. It's been shifted up 10, so you got this upper part of the W. It intersects with function s, which forms the upper part of the right part of the W. That's all in the book. I just copied it up here. So you're supposed to find the area of this W.
Oh, wow. Wow.
Crazy you can do that.
So how are we going to attack this problem?
You could look at it piecewise.
Yes, we're going to have to break it up in pieces. That's right. The first and most obvious split up is right here. First most obvious split will be right here, halfway between 12 and 24. You see that these two functions intersect right there, as do these two functions. So whatever that number is, halfway between 12 and 24 is 36, which is 18, I guess, or something like that.
Are the both sides of the W symmetrical?
Question. Only if both sides of the W are symmetrical would that be true. And they are symmetric because, good question, they're symmetric because the coefficient on both of the F and the G and on the S and the R, those coefficients are the same coefficient, 1, 1 here and 0.5, 0.5 there. That makes the shape of the W be symmetric. So the midpoint would be the intersection. So clearly we're going to have to split it up. Are you with me? We have to split it up at 18. That's the. Well, what else has to happen? Does it start at 0 is the question. No. How do you figure out where it starts? Like, it's not starting at 0, x equals 0, it's starting like right there. How do I find, that's my starting place. I got to split it up at 18. I'm not going to have to split it at 12. So how do I find that starting position right there? There's also an ending position over here. Any ideas?
Are you gonna plug in like 0 for something, or are you gonna plug in a vertical number?
Yeah, which one?
Well, I'll tell you what.
I'm going to guess it's one of those two since you only have X and Y, so you're going to plug in for one of them. You're right.
Yeah. I'll tell you what. It says that the top height is of 55 feet.
He already has that.
Okay.
Yes. So, are you gonna plug 55 as the Y value for like the f of x is equal to 0.5
So F of X
well,
equals 0.5, or not, it's 55. So yeah, then you're going to solve F of X right here for 55, you're right.
Got him.
Do that for me real quick. Let's see. So divide by 0.5 is 110. 10. X minus 12 squared.
Wally's Burger Shack.
Well, X equals 12 plus root of 110. Or it might be minus root of 110.
I love
Which
it.
one is it? When you do the root, you got plus or minus, right? So is it 12 plus root 110 or is it 12 minus root 110?
Is it both?
Oh yeah,
Understand that function f of x, here's function f of x, this bottom part of this loop. It's going to rise up, if I were to continue drawing it, function f of x would rise up, it would come up like this, and it would hit 55 again right there. So f of x hits 55 twice. We all see this? In theory. So which one are we going to really use here? Left one. There's a left and a right intersection at 55. Which one is the left? Of y. Okay, so the start is at 12 minus root 110.
Oh, that's cute.
How are we going to find the end value, folks?
Oh, what are you gonna do? Plug 55 in for, what was it, g of x?
Yes, so we'll use g of x. So we'll use g of x equals 55. So that means 0.5 x minus 24 squared equals 55. X minus 24 squared equals 10. So x equals 24 plus or minus root 10. Which one is it? Is it the plus or the minus?
The plus.
It's the plus.
It's the plus because we need the right-hand side this time instead of the left-hand side. So this will be x equals plus root 1. Okay, that's going to be the end. Well, at a minimum, we should visualize that we're going to integrate, we're going to set up an interval from 12 minus root 110 to 18. And then from 18 to 24 plus root 110. At a minimum. However, there's another little hiccup in this problem that makes it more complicated. So, like I did over there when I talked about rectangles and I talked about the high bound and the low bound of the rectangles, do you remember this? Let's look at this picture. Is it always going to be, like for example, in here, it's pretty obvious that, for example, in this region right there, if I do a high and a low bound and make my rectangle, are you with me? But the upper part of my rectangle is going to be defined by r of x, and the lower part of my rectangle is going to be defined by f of x. So for that rectangle right there, that rectangle, the height is simply r minus f. Are we all in agreement with that rectangle right there? Now my question is, here's the question, will this r minus f always be true for every single rectangle between the start and 18? So I'm focusing, right, all my attention is between start and 18. And I've got, imagining a bunch of rectangles, you know, a bunch of, like we've done for Riemann sum. Got a bunch of rectangles in here. So all of those rectangles, will they be bounded by r minus f like we've done right there in this region from start to 18? That's the question. Yes. The answer is no, or else I wouldn't have brought it up probably. Because right here, notice what happens there. Until you get to that green line, all of the rectangles are in fact r minus f, all the way through there. But what happens happens between start and green line. It's always going to be 55 minus F. 55 minus F. We all see how that's the height of those rectangles up there?
Yeah, I get you.
So what that means, besides the three numbers I've already figured out, I need another number. I need that number right there. How do I figure out? So for a small interval there, I've got rectangles that are not bounded by R, but they're bounded by 55 and L. I need to know what that number is so I can set up an interval for that.
Yeah, I'm gonna say it's 6.
You're going to say it's what?
I'm gonna say it's 6.
How'd you get 6?
Because I'm looking at the picture on the book.
Oh, you're looking at the picture on the book. I'm looking at the picture on the book. It might be 6. Might very well be 6. How can we verify that it's 6? Yeah, we have to set R of X equal to 55 now.
Oh, I get it.
So R of X has to be 55. So that means we've got X minus 12 squared plus 10 equals 55. So X minus 12 squared equals 45. So X equals 12 plus or minus root 45. Sadly, I don't think that's going to be exactly 6.
Well, you know what? Something close to it.
Close to it. A little less than 6, I guess.
Yeah.
Or maybe a little more. Which one is it? Is it the 12 plus root 45, or is it the 12 minus root 45?
Don't tell me it's the minus.
It's the minus.
No.
It'll be the minus this time.
Versus.
Okay. And guess what, folks? You're still not done. From what you've just seen, what else can you observe?
There's
Plus
another
of the X.
green line.
4 plus
Yes, when you get over here, all of your rectangles are nice and pretty with an upper bound of S. This is S minus G. That's easy. But once you get to that point right there, things change once again. So you got to do when S is equal to 55. So S of X equals 55. So that's plus 10. So that's just going to be X equals 24 plus minus root 45. Which one is it this time, the plus or the minus?
Plus.
Plus, because we want the right-hand intersection. So X equals 24 plus root 45. So in summary, let's use all this information to write up what the intervals would look like. Find it.
Okay, do you want to be in the middle?
I think I'm going to write it in the middle because I don't have room over there. But I'm going to have to kind of guess, pan back and forth. Hopefully everyone's got a sort of idea. Yeah, may not be able to see all that. I guess, can you kind of capture part, maybe pan back just a little bit? Get a little bit of both forward, maybe. Okay, so let's write them all up in a stack. So what's my first interval going to look like? Minus root 110 to what? To 12 minus root 45 of what?
Let's do f of x minus.
The upper bound minus the lower. We're doing the idea of f minus g in general, but in this particular situation, you want your upper function minus your lower function in this interval. So in that short interval, what's the upper function? 55 is the lower function. 55 minus whatever f of x is, 0.5 times x minus 12 squared dx. Okay, now what's the next sum? I'm just breaking up my interval. What's the next interval, and what's my interval? Integral over the next interval. Look like. And it's root 45 up to what? 18, right? What's the upper minus lower function here? Upper minus lower. The r minus f is correct. So that's going to be x minus 12 squared plus 10 minus f was 0.5 times x minus 12 squared. What's the next interval and integral?
Did I reserve this fight?
That's 18 to 24 plus root 45. S minus G. So S is x minus 24 squared plus 10 minus G is 0.5 x minus 24 squared. And then finally, 24 plus root 45 up to 24 plus root 110. Minus G, so that'll be 0.5 times x minus 24. Now all you have to do is find the antiderivative and plug it stuff. All right, well, I guess we're cut out of time. I can't remember which ones were assigned in the homework. Was that one even assigned in the homework? For homework tonight, besides practicing some more, you need to do some more practice of finding the assigned area versus the absolute area. Between functions and between the x-axis in the same section, but also do, even if it wasn't assigned, go ahead and do problem 76 on page 387, just for, see if you can figure that out.
76.
76.
We got it right.
76. We'll talk about them all, see how you do.
All right.
All right.
I'm just gonna.
Then we have a real application problem. And the numbers won't come out pretty. Right, see old mom?
You know they use the same kit in gaming and simulation software. That's how things work under the hood in our gaming software.
Yes. Yeah, those. Oh, you're gonna get one. Programming. Depending on the type of the base station, you don't generally calculate.
It depends on what database you're doing on database. Yes. If you're doing, well, but if you're doing gaming in Vegas programming, yes.
Yeah, that's true.
Okay, but if you're doing hospital stuff, not so much.
I still don't feel good.
Yeah. We'll see.
Where's my corrections?
I'm the worst kind of sick. When you're tired all the time, but you can't even sleep. You're in constant discomfort.
Are you gonna intern?
I don't know.
But don't you love interning, Chloe?
I do actually.
We have to make an hour to do.
We don't have to.
We have to. Why do I have to? No, I have to.
Oh.
Me, Raizo, and Lily.
They're suggesting we
Have
do.
fun.
No. That was just like, this needs to be done.
I see how it is. Can you hear me though?
I'm really getting
Right.
Oh my goodness, we're already at the point where we're buying our classes now.
Yep.
Or what?
Wait, are we buying them like now?
He sent out on Canvas an announcement with the link to buy them.
Wait, you had to buy them
Just
online?
close it.
Yeah,
You have to buy them through the Herb Jones thing.
Okay.
How much are they? Like $100? Probably.
I'm looking right now. Oh my.
How much is?
Are they just really
blue
big?
or are they black?
Okay.
I hope they're
What
blue.
color are they?
I hope they're blue.
I'm okay with either. I'm not too picky.
I want blue because last year was black.
Black isn't bad.
I know, but we normally alternate.
Okay,
Yeah.
so you can buy packages or you can shop individually.
Nice.
The cap and gown,
I see myself in
Don't you
blue.
just
the
need
cap,
the
gown,
cap
and tassel unit is $30.
Hey, that's not bad at all.
That's not.
Yeah.
I thought it was like.
But then you can get packages where it's
I
like,
just want to keep tassel.
okay,
You get to keep it all.
Really?
Yeah.
Oh,
If you buy it, it's yours.
Oh, cool.
but you can also get packages of stuff, which I think is a better deal if you're buying multiple things. So it's like cap, gown, and tassel unit, 25 traditional graduation announcements, a graduate name card,
The
memory
announcement.
tassel, mega tassel. How
Mega
many
tassel.
tassels do you need?
20.
Tissue inserts, class envelopes, seals, traditional return address labels, traditional thank you notes, diploma plaque, dog tag necklace, other tassel picture frame.
I think this is.
That's not the next
That's a bit much.
Yeah, you're right.
If you're wanting to pay $274.